When people think of recovering rockets, the image that usually comes to mind is SpaceX's Falcon 9 extending its four landing legs and touching down on the deck of an autonomous drone ship. Or, even more dramatically, catching a giant rocket mid-air with the launch tower's massive mechanical arms. But that's not the case anymore. China has now shown up and literally fired four hooks into a giant net stretched across a ship at sea to catch its rocket. So, the obvious question is, how do these completely different rocket recovery systems stack up against each other? And does SpaceX finally have to watch its back? Could China actually challenge its throne in the reusable rocket game? Well, let's find out. First, let's do a quick rundown of what actually happened. The Long March 10B lifted off from Commercial Launch Pad 2 at the Wenchang Commercial Space Launch Site at 12:15 p.m. China Standard Time. Right from the start, everything appeared to go according to plan. Its 7 YF-100K engines powered the rocket through the first 2.5 minutes of flight before shutting down for stage separation. Moments later, the second stage's YF-219 engine ignited and continued the climb to orbit, successfully delivering the mission. After separating, the first stage booster didn't simply fall into the ocean like traditional rockets. Instead, it turned around and performed a controlled return toward an offshore recovery ship called Linghangzhe. During re-entry, 3 of its engines briefly reignited to slow the booster down, protect it from the intense heat of re-entry, and fine-tune its trajectory. Nearly 10 minutes after launch, the booster fired 3 engines one final time before throttling down to a single engine for the last few moments of descent. But instead of unfolding landing legs like Falcon 9, it aimed directly for a giant net suspended on a recovery platform. Somehow, and I still can't believe this sentence is real, it gently settled into the tensioned steel cables and was successfully caught about 430 kilometers downrange. And with it, catching rockets in midair isn't just a SpaceX thing anymore. So, naturally, the part everyone's most curious about is this strange recovery system. What exactly is it, and how does it work? I've actually made a video on this system before, where I also dive into the history of how China developed it. So if you want the full backstory, be sure to check that video out. But today, we're focusing purely on the mechanics, how this system actually works, how it functions, and how it compares to other rocket recovery methods. The vessel that catches the ship is a converted, non-self-propelled, flat-top barge with no engines of its own, redesigned by teams from China's space industry, shipbuilding industry, and even deep-sea research institutes. It's a pretty massive platform, measuring 144 meters long, 50 meters wide, with a full load displacement of 25,000 tons. But the really important part is its DP2 dynamic positioning system, which constantly fights the wind, waves, and currents to keep the ship sitting almost perfectly still, because catching a falling rocket is a lot harder when your catcher won't stop drifting around. And this is the star of the show: the giant cable net capture system. Instead of landing on a deck, the rocket aims for an enormous web of tensioned steel cables stretched across an area about 40 by 60 meters. The cool part is, the net doesn't just sit there. It's mounted on a pulley-driven system that can actually shift and realign itself to match the rocket's descent, basically trying to meet the booster halfway instead of expecting perfect aim every single time. When the rocket's hooks latch onto those cables, the job isn't over. The vehicle is still carrying plenty of momentum, so a huge hydraulic damping system gradually absorbs that remaining energy, bringing the rocket to a controlled stop instead of letting it slam onto a steel deck. Think of it like one of those giant safety nets that catches circus acrobats, except the acrobat weighs hundreds of tons and is filled with rocket engines. As you can probably guess, building something like this was a lot harder than it sounded. According to chief designer He Guangwei, normal ships don't have to worry much about constantly matching the roll, pitch, and yaw of a falling rocket. This one does. Its positioning system has to maintain incredible accuracy from every wave direction, because even a small movement could throw off the entire recovery. The structure itself created another engineering headache. Normally, a ship spreads weight fairly evenly across its deck. This one has a gigantic 67-meter-tall capture tower weighing around 3,500 tons, about 5,400 tons once all the equipment is installed, supported by just 4 massive pedestals. That's like balancing an apartment building on 4 table legs and expecting nothing to bend. And because that tower sits so high above the deck, it raises the ship's center of gravity, making stability a much bigger problem. To counter that, engineers installed large sponsons at each corner of the tower. Whenever the vessel starts to lean, these structures dip into the water and generate extra buoyancy, helping reduce the roll before it becomes an issue. The engineers also spent years running simulations, analyzing loads in different sea conditions, performing wind tunnel testing, and redesigning the hull before finally arriving at a platform they believed was stable enough to catch a descending rocket. And once it's out at sea, the whole thing can even be operated remotely. Crews simply upload the recovery coordinates from 10 to 20 kilometers away, and the ship automatically sails, or rather holds itself, at exactly the right location, waiting for a rocket to fall out of the sky. Okay, now that we have a much clearer picture of how China's new recovery system actually works, we can finally compare it to SpaceX's approach and see where each one shines. SpaceX has already mastered propulsive landings with Falcon 9, routinely bringing boosters back to drone ships or landing pads. Then, with Starship, they took things a step further by catching the Super Heavy booster directly at the launch tower using the giant mechanical arms known as Mechazilla. Right away, you can see both systems are chasing the same goal: eliminate heavy landing legs to save weight and carry more payload. But after that, the similarities end. Instead of making the rocket support itself after landing, both systems move that complexity into the recovery infrastructure. SpaceX built an enormous launch tower with giant robotic arms. China built a massive floating recovery platform equipped with a suspended capture net. Perhaps the biggest advantage the China system has over Mechazilla is that the rocket does not have to be extremely precise for it to work. Instead of trying to squeeze perfectly between 2 giant mechanical arms, the booster just has to make it into the capture zone. Think of it like parking in a wide-open Costco parking space instead of trying to parallel park on a busy street. One is definitely a lot less stressful. That wider capture window is one of the biggest strengths of China's design, and it's probably why they chose a giant suspended net in the first place. The cables can flex, absorb energy, and tolerate a bit more horizontal error than a pair of rigid steel arms ever could. But don't let that fool you into thinking it's easy. The booster still has to descend almost perfectly vertically, control its speed, stay rock solid, and guide itself into a roughly 54 by 54 meter opening while hovering over the middle of the ocean. That's still an incredibly difficult target to hit, and it has to do all of that in about 6 minutes. After stage separation, the booster flips around, performs a powered deceleration burn, slows further using aerodynamic drag, and then lines itself up so the net can safely catch it. Meanwhile, the recovery ship also has to hold an incredibly precise position despite floating on, the ocean, which has a bad habit of moving. So yes, the net gives the booster a little more breathing room during the final catch, but the overall recovery is still a seriously impressive engineering challenge. Another trade-off is that offshore operations are usually always suck. Because the booster is recovered hundreds of kilometers offshore, someone still has to bring it home. That means ships, weather delays, rough seas, and a whole lot of logistics before the rocket can fly again. SpaceX takes almost the exact opposite approach. By catching Starship's Super Heavy booster right back at the launch tower, the company can inspect it, refuel it, and get it ready for another flight as quickly as possible. That's a huge part of SpaceX's long-term vision of making rockets operate more like airplanes. The catch, literally, is that Mechazilla demands incredible precision. The booster has to perform a boost-back burn extra propellant to return to the launch site, and then fly with astonishing accuracy between 2 massive mechanical arms. Miss by too much, and you're not just risking the booster, you could also damage the launch tower itself. So in the end, both systems are solving the same problem, just with very different priorities. SpaceX is betting everything on the fastest possible turnaround and rapid reusability, even if that means demanding near-perfect landings. China, meanwhile, is willing to accept slower sea-based recovery in exchange for carrying more payload and giving the booster a much more forgiving target during the final catch. This is still a big deal because until now, SpaceX has been the undisputed king of reusable rockets. They've landed Falcon 9 boosters hundreds of times, reused some of them dozens of times, and they're now pushing things even further with Starship and Mechazilla. So the fact that China has now demonstrated a successful first-stage recovery is significant. It doesn't erase SpaceX's lead, but it does show they're beginning to close part of the technology gap. Now, does that mean China is suddenly challenging SpaceX? Yes, but with a pretty big asterisk. A lot of headlines make it sound like China just showed up and is going toe-to-toe with SpaceX overnight. That's not really what's happening. SpaceX isn't just good at recovering rockets. They've turned rocket reuse into a routine operation. They have hundreds of successful booster recoveries, a mature refurbishment process, regular commercial reuse, and some of the lowest launch costs in the industry. China has achieved an important milestone. But one successful recovery isn't the same as running a reusable launch system every week. It's kind of like someone building their first electric car. That's genuinely impressive, but it's not the same as building millions of them every year. One proves the idea works. The other proves you can make a business out of it. And that's exactly why this matters. Recovering the first stage is the single biggest way to reduce launch costs, which is why China has spent nearly a decade working toward this moment, progressing from small hover tests to full orbital recoveries. According to the mission team, this flight wasn't just about catching the booster. It also validated a whole list of critical technologies, including the rocket's overall design, its methane propulsion system, propellant management, multiple engine restarts, high-altitude ignition, precision guidance and navigation, and, of course, the offshore net recovery itself. In other words, this wasn't just a flashy stunt. It was a systems test, and by all accounts, a successful one. But the real test is still ahead. The Long March 10B team says they plan to fly this recovered booster again before the end of the year. And honestly, that's the moment that really matters. Because a rocket you can catch once is cool. A rocket you can catch, inspect, refuel, and fly again quickly? That's what actually changes the economics of spaceflight. So, what do you think? Does this unique Chinese recovery system have what it takes to challenge SpaceX's dominance in reusable rockets? Drop your thoughts in the comments. What's cool is that this is really China's own approach. Innovation doesn't always mean inventing something nobody has ever imagined before. Sometimes it's finding a different, and maybe even better, way to solve the same problem. Now, could China eventually build reusable rockets that are nearly as capable as SpaceX's, but at a lower cost? It's possible. But right now, nobody knows. One successful demonstration doesn't tell us how expensive refurbishment will be, how reliable the system is, how quickly the booster can fly again, how many times it can be reused, or what each launch will ultimately cost. Those are the numbers that decide whether a reusable rocket is just technically impressive or commercially revolutionary. Finally, here's something interesting that almost got overshadowed by China's announcement. Just one day after China revealed its first successful reusable first-stage recovery using a giant sea-based capture net, Japan showed off a reusable rocket milestone of its own. Japan Aerospace Exploration Agency, or JAXA, successfully flew and landed its reusable rocket prototype called RVX. Now, don't expect anything too dramatic. The rocket lifted off, climbed to about 10 meters, or roughly 33 feet, hovered for a few moments, and gently landed back on the pad. The whole flight lasted around 40 seconds. That may not sound very exciting. Your microwave probably gets more action on pizza night. But that wasn't the point. The goal wasn't to reach space. It was simply to prove the rocket could take off, hover, and land under its own power. And believe it or not, that's one of the hardest parts of building a reusable rocket. A successful hop test means the guidance software, navigation system, engines, and landing controls all work together exactly as planned. This is basically what SpaceX did back in the day. SpaceX also started with small hopper tests long before Falcon 9 was routinely flying to space and landing back on Earth. The difference is scale. JAXA's RVX hopped about 10 meters and flew for roughly 40 seconds. A Falcon 9 launches payloads into orbit, flies hundreds of kilometers downrange, reaches hypersonic speeds, survives re-entry, and then lands itself about 8 to 10 minutes later. So while both involve vertical landings, JAXA is still proving the fundamentals before moving on to much more challenging flights. Interestingly, JAXA isn't even the first organization in Japan to pull this off. In 2025, a research subsidiary of Honda, became the first Japanese company to launch and vertically land a reusable rocket prototype. That was a private sector achievement. This latest milestone comes from Japan's National Space Agency, meaning Japan now has both government and private organizations actively developing reusable rocket technology. And that's probably the most interesting part. Countries around the world are no longer asking whether reusable rockets are worth pursuing. They're asking how quickly they can build one of their own. Why? Because reusing rockets is one of the biggest ways to slash launch costs. It means launching satellites more often, growing a competitive commercial space industry, and relying less on expensive single-use rockets. One thing this flight does make clear, though, is that the race is getting more interesting. SpaceX still has a massive lead, but no company stays on top forever simply because it got there first. Competition pushes everyone to innovate faster, solve harder problems, and build better rockets. And if history has taught us anything, it's that today's leader is never guaranteed to be tomorrow's.